Hello, IED students. Today we are going to begin Unit 4, beginning with 4.0, which focuses on modeling. This screencast is going to walk you through the modeling presentation. As usual, you should be taking notes on this presentation. The Bitmojis are indicated for the slides that you do need to take notes on. The sequence of this presentation basically goes that there's a note-taking slide and then a few slides filled with examples. I'll be going all over all of that information, so make sure you have your notebook ready and let's get started. So first, modeling is the act of representing designs or ideas in various forms in order to present or evaluate a design. All we're doing is that we are finding a way to represent information so that it makes sense. Now we have different types of modeling. The types that we're going to talk about in this presentation are concept modeling, graphical modeling, mathematical modeling, computer modeling, and physical modeling. I know some of you can probably guess as to what some of these are because you've talked about them or used them in other classes, but we're going to do a brief overview of each of them. So let's start with concept modeling. Concept modeling is when we list or map concepts in a process or something that we're investigating. So the example on this slide is that we're designing a theme park. So maybe the first step to designing that theme park would be to create a list of the rides that we want, the different attractions that we would have in there, and the facilities that would be included in design. So things that we would have to consider would be easy access to major transportation. So maybe it needs to be close to something like a metro line. It should have a circular pattern of attractions, so that way it's easy to navigate within the park. Maybe it has to have a theme, so either fairy tales or different countries or a sports theme, and then access to emergency medical facilities if someone were to be injured. Other things you can consider: bathrooms, changing areas, that kind of thing. So here's another example of a concept model. So this one is an example of how you would solve global warming. So this is basically a tree map. So what you're looking at is you have the problem in the center, and then there is different branches that come out of that circle. So we have create change, where you can plant trees, you could vote, or you could learn more about the topic, different ways that we could use energy differently, different ways we could alter our travel, okay, how we could work with changing our diets to help solve global warming, and then less waste, all the ways that we could create less waste. So this is an example of a concept model, how we break things down into different areas. We take a big problem and then we break it into smaller areas and then subdivide it even further. So now we're going to talk about graphical modeling. Graphical modeling is when we represent information in the form of charts, graphs, maps, or any kind of geometric figure. So this is an example of an ocean floor map. So you can see the different depths based upon the darkness of color, how shallow the water is, where we have reefs or any kind of landmass, that kind of thing. So this is a topographical map that shows different heights or elevations. Okay, another example of a graphical model are sketches and drawings. Okay, we talked about concept sketching and we've done a lot of technical drawing. These are all examples of graphical modeling. So you guys have actually secretly been graphically modeling for about a unit and a half now. Okay, graphs and charts also can be graphical models. So we just talked about histograms and different types of graphical modeling that we can use with data analysis, and that falls under graphical modeling too. So a pie chart, a bar graph, a dot plot, a histogram, all of that falls into the graphical modeling category. And then we have mathematical modeling. So using mathematical equations or geometric representations to predict or model a phenomenon or a behavior. So things like solving for the volume of a cylinder. Okay, we have a consistent formula that we follow, and if we were to represent it in this way, okay, that's partially a mathematical model as a formula, but we can also represent it this way. That is definitely a mathematical model because it's representing this formula in a visual manner. So that is one example of a mathematical model. Okay, this is another example of a mathematical model, and that is the garbage production in York County. So looking at this, we have a scatter plot of the garbage production in York County where we track years, t being 0, and that represents 1970, and then time increases, and then we have the amount of garbage on our opposite axis. And then moving into computer modeling, this is where we use a computer and software to create a representation of an object or a concept. So this is where we take an idea and we turn it into an actual visual representation on a computer. So this can include 3D modeling of different parts, modeling of structures for structural analysis, modeling circuits to make sure they're going to work properly, or modeling chemical processes to make sure that we're not going to have any nasty byproducts that are going to hurt the environment or us. So these are all different ways that we can use computer simulations or modeling software to create models. So here's an example. This is a soap dish design. This was done in Autodesk Inventor, which is actually the software we use in class. So these are all 3D models that were created and designed inside of Autodesk Inventor, which is software you guys are actually going to be using in this unit. Okay, this is a structural frame analysis. This is also probably done in Autodesk Inventor as it has a frame analysis feature. So what this is doing is it's applying force at the blue arrow. The red arrows are then indicating where the force is being pushed onto the frame. So if there were any breakages or things like that, we would get an alert and it would tell us where we have to redesign the product. Okay, now this is an example of a circuit model or a circuit schematic. My digital electronics students work with these all the time. This is actually an example of something they create in class. So this is a manufactured device. So this is what it looks like when you go to Walmart, Target, and purchase these things, or Amazon. This is an example of what it looks like when you're designing it. This is the schematic that you create, all the different parts that go into an electrical circuit, and that then turns into an actual hardwired circuit. This chip right here is called an S7, and it's like a mini computer brain that controls all of these other things that it's wired to. They're really cool. Here's some more examples of computer aided for modeling based on computer manufacturing. This is Autodesk Inventor, and what it's doing is it's actually working on a CNC process. So this would start as a block of wood, and this would then carve out different material to then create this guy over here. So that's another way that we can use computer modeling in the manufacturing world. So now we're going to talk about physical modeling. This is probably the one you're most familiar with, where you actually physically make something as a representation of an object or concept. So we have a mock-up. That's an appearance model. So that means that it just is meant to generally look like our idea. And then we have a scale model. That's similar to a mock-up, except everything is either the same size, larger or smaller, but mathematically correlated. So that means that we have a representation of it, so that way we know what size it would actually be. And then a prototype is a working model of the actual design. So if you think back to instant challenges, some of you just created mock-ups of your idea. Some of you had scale models, but many of you had prototypes during those instant challenges where it was actually a working model of your actual design. So again, you've been doing physical modeling for the entire school year and probably longer. Okay, so here's an example of a physical model. This is a scale model of a house. This is probably from one of the architecture classes that PLTW offers. And so you can see the different layers of the house built in here. And obviously it's not the size of a real house, but I bet mathematically we could figure out how big the real house would be based upon this model. Okay, so this is a mock-up. So this is a keychain. All right, and then we have an automatic dog feeder. So these are things that are actual representations of those items that are mock-ups of those two items. And then lastly, we have a prototype. So this is something that would actually function. I'm assuming this is some kind of wind-powered something. So this actually would function and do what it needs to. And then over here, we have a cross-country training ski. That, again, is a prototype because it actually works the way it's supposed to. And then a visible toaster is the last example of an actual prototype. All right, so that concludes this presentation. If you need to go back to fill in any areas of the notes because you did not hit the pause button while the screencast was happening, hit that rewind button and go back, make sure you have everything filled in, and then you can get started on the activity for 4.0. All right, thanks. Bye.